Good morning. There was a time when all the home computers were boxes sized like this, and pretty much best what you could do with them, save your mom's cooking recipes. And at the very same time, cars, very simple machines. Best technology that driver could actually use was probably that small green clock in a dashboard. But if you look cars of today, connected, a lot of stuff, navigator, computer, everything which would make the supercomputer of that time really jealous of all the computing power they have. And that's not just cars. Aircrafts. Airbus is predicting that number of passenger aircrafts in the world will double in the next 2 decades. That will mean probably 50,000 concurrently operating planes on the air. Rolls-Royce is designing and planning to have first full electric airplane on the sky on 2022, which is 3 years from now. And from that plane, there's 20,000 data points they are collecting per second on the plane. And if you multiply that amount of data, put that to all planes on the air, you get a massive amount of data. Someone has calculated it's almost 100 exabytes by 2026. Sounds about right, who knows? Artificial intelligence. That's a computing which basically is computing from data they have been collecting, they are collecting right now, or they are absorbing through the sensors. But that's all based on data they have available. For example, autonomous ships. There are projects in Finland at the moment where ships, imagine large container ships, huge ones, are being cruising the sea without human intervention. No humans on board. Imagine what amount of data is needed just to get that ship from, let's say, port of Helsinki to New York. No humans. What can happen on the sea? What are all the options they have to actually to be able to handle? Huge amount of data. Autonomous cars. We all have seen what's the development in past years, but it's not there. All the data which is needed just to operate all this stuff, that's estimated being almost 200 zettabytes within the next 5-6 years. That's a huge business. That requires a lot of new ways to address data, how you move that data, where you move it, where you handle it. You just can't collect all that data available in one location and process it there. You need to know how and when you actually, and what you will do with that data. And having that all data, that creates a huge, massive market. It's quite $1 trillion. And it's a market which is basically not anything which is being done right now. So it's a new market. How do you dig the data you need from that mass you have, from that mass which you actually have all around the world? You are all familiar with IoTs. IoT is spread all over the world. So change from having data in one data center is moving. It's been moved around the world. It's on the edge. It's closer to user, where you have to have it. Your user in Singapore or Dallas or Helsinki, it's not realistic that you actually can do same thing, same place for all users all over the world. So you need to be really careful when you design how you access the data. And generally, IoT market, I mean, no one probably disagrees that it's a big one. That's why we are here. But it's estimated in the next 3 years, this would be around 1 trillion business. It's 3 years. And if you look down a little bit here in a small Finland, what's happening here? Finland is actually we have a chance here. We have a project for autonomous car, autonomous ships. There's an example project called Aurora, which tries to create legally possible circumstances and environment for fully autonomous driving cars on road conditions. And Finnish advantage is actually that we are not sunny California. We have snow, we have hail, we have rain, we have slush. So if you can get a car work here in northern Finland or southern Finland, it works pretty much everywhere. But otherwise, Finnish transport terms, they are following the global trends. Urbanization. Cities are growing, basically. 85% people are living in cities, and it'll grow. Trend continues. Cities need to solve how they actually deal with the increasing traffic. And if you combine it with, for example, autonomous car, autonomous bikes, whatever, pick your favorite transport method, you need to deal with it. Ground traffic. 3 million cars. Some portion of them are actually alternative power. Some are not. But overall trend is cars will be more connected. There's an estimation that within the next 3 years, world has 400 million connected cars. At some level, they are not fully self-driving, but connected. Most of the new cars coming on the traffic today have some level of connectivity. Significant increase in air traffic. Finnair had a good year, yes, but also Helsinki Airport, 20 million passengers. That's a lot for an airport size of Helsinki. Railway increasing, 130 million journeys last year. Just count how many journeys it's per person in Finland. And all this will be more and more connected. People are expecting that they have the phone they have in their pockets. They will get all necessary information to use that transport. So if you look at connected vehicle, it doesn't need to be a car, it just because it's a nice icon. Can be as well train, bike, a boat if you wish. There's a huge ecosystem around it. I mean, car won't work as itself. It needs the data. And it needs data from somewhere, but also the partners need to know something about the car. Mobility as a service. That's a big trend with the big automotive manufacturers. They are expecting that people, they don't want to own the car anymore. They want to spend the car. Whether true or not, but remember what was music industry 10 years ago. Apple was really convinced that people really want to own the music pieces they have. They started to sell music, 99 cents per piece. So how it went? Not well, I guess. I mean, today, most, if not all, music is consumed by streaming. Monthly fee, and use how much and whatever you want. And the car manufacturers, they expect that the same will happen in the car industry. Emergency. Imagine if you have a self-driving car, and there are chances that if it's self-driving, it's also driving alone, without human on board at all. What if something happens? Okay, the easy one is if there's a car crash. Call 112. But what if the connected vehicle bypasses an accident? What it do? How it should react? Should it stop? Should it call? Should it stay? I don't have an answer, but there's an awful lot of companies who are solving that at the moment. Insurance. Yeah, I think they have better days coming, because when the car is connected, they can actually see your driving habits in the future. And they actually can have a data and see what has happened, because probably most cars will have cameras in the future. And the cameras don't lie as the humans tend to do if there's an accident. Telematics. For example, EU has at the moment thinking of legislation, mandatory legislation, that cars would be followed by GPS, by cams, whatever the mean is, but in case you overspeed, car will break down. So when you connect vehicles to the net, you get a lot more new opportunities, or threats, if you wish. Predictive maintenance. A lot of service companies who would love to get an information that your car is just about to be broken and offer you services. And even better, there might be spare part sales companies who actually would like to offer you spare parts. Fleet, logistics management, where the cars are, if they are driving alone, but even though they wouldn't be, that's still because the cars are connected, you get a lot of new opportunities to optimize how to use your fleet. And remember, this is not just cars, trains, bikes, whatever you wish. Traffic management. Well, connected car, predicting traffic congestions, much easier. But the interesting question is actually, can we avoid traffic congestions if most of the cars are connected and they are actually sending their routes centrally somewhere where you can pick, kind of balance the traffic, as you would say. And the question is, do we need the traffic lights if we have self-driving fleet? I don't know. But it sounds to me that the cars could actually negotiate them by self. Point here being, connected vehicles, there will be an awful lot of them. There will be a lot of related companies. The ecosystem will be pretty large, and you need to somehow tackle and find out how you actually move the right data to the right place on the right time. Because you can't share all data with everyone. That's not sustainable, and I mean, probably could make some harm to how do you find a way to transfer the data all over the world? And from that basis, traditional VPN-based internet has a predicted growth of 7%. It's nice if you are a kind of old telco having 7% growth. That's nice. Internet, well, not everyone even have an internet yet, so that's not a surprise that it will grow. It's predicted to grow 26% if you look at 17 to 21. And probably will continue growing even after that. But interconnection is predicted, which means direct connection between the parties has been predicted to grow faster than internet. The 50% growth in 5 years. And actually bypassing the volume of bandwidth of internet in 5 years, or actually a bit faster. There's actually a nice study if you want to dig in more details. Let me give an example. Navigator in the car, simple device, right? It looks where we are, points where it should go. But if you've been using those a lot, you know that once in a while, you get an alert, kind of eyes on the road, animals, traffic jam. How does that work? Do you think if you have a Japanese car driving here, they will send that data from Japan to Finland to see that there was a moose in a Porvoo highway 10 minutes ago? No. There are awful lot of companies collecting the data from all the sources. The example here I'm using is a V-Traffic. It's actually Finnish-based activity. They collect newspapers, officials, road cameras, all the sources they need. They'll connect all the parties, track the information, and send it to navigators on the area of interest. And chances are, if you have a German, Japanese, or Swedish car, you are using their system already. Another example, Siemens, having installed 300 sensors to trains, just to have an overview how the train is doing. Do we need to maintain it, have a maintenance for the train? That's such a huge amount of data they are getting that they just can't deploy that over to the internet. So they needed to find a way how to do it. So it's basically connect directly to ecosystem partner on the area you are actually working. Not to collect all the data from all the trains to Siemens, then do something and make a decision. But actually connect to partner, which in this case was a company called Teradat. There's a lot of analysis companies, which make a data processing on the area they are working and return the results to Siemens. So kind of what we've been seeing globally, Equinix has 200 data centers globally. And the current trend, what we are seeing, is that data processing has been centralized, but has been pushed closer and closer and closer to the edge, close to the end users. And if you think that all the data available here, and you are developing an IoT platform here. Just my message to you is just think how you scale. You just can't scale building a stuff and deploying it to AWS. That's not sufficient. You need to know where you are, where you will work, what you will do, and then you need to be close that activity. And when you get to 5G, that even multiplies it, because the data volumes through the 5G, they are even bigger. Point of this slide is just that there's a lot of partners. You can connect them, but you need to know what you want to do. How do you want to deal with the data? That's your biggest challenge in the next 5 years. It's not technology. It's not what you could do, because you can imagine a lot. But you need to plan how do you get there. Thank you.